Let's begin. Today's May 6, 2024, and we're doing our Daily Turing Machine Puzzle. Notice our 6 criteria cards and our 6 verification cards. But before we begin play, I invite you to go to turingmachine.info and download the note sheet. If you notice, I've adapted the note sheet to accommodate my screen. I wrote a program that'll keep track of my proposals and the responses by the Turing machine. I moved the digit selection portion to the top and wrote all of my notes vertically. So let's begin. We see that again we have our 6 criteria cards, A, B, C in the top row and D, E, F on the second row. Now let's look at each one individually. The first criteria card, A, compares the middle digit, the square digit, to the number 3. Is square less than 3? Is square equal to 3? Or square greater than 3? Criteria B will confirm whether the middle digit, the square digit, is either even or odd. Criteria C will then inform us whether there are no 3s, 1, 2, or all 3 digits are 3. Criteria D compares the middle digit and the third digit, or the square in the circle, and confirms whether the square is less than the circle, is a square equal to the circle, or a square greater than the circle. Criteria E sums up the first 2 digits, the triangle and the square, and compares that sum to the number 6. Is the sum less than 6? Is it equal to 6? Or is the sum greater than 6? And finally, criteria F will inform us whether the 3-digit code has all unique digits. Could the code have a pair of digits, or could all 3 digits be the same repeated 3 times? Remember, we're trying to find a unique 3-digit code where every criteria is met or is fulfilled. Okay? We started off by having our first proposal be 314, and I believe I'm going to test criteria B, whether the middle digit, the square digit, is even or odd. So let's test B. Okay, so the Turing machine says that no, and if I look at my proposal, I have an odd digit. So the Turing machine is informing me that no, the middle digit cannot be odd. The square cannot be odd. So I'm going to go into my notes here, and I'm going to say for B, square is even, right? If it's not odd, it's even. Square is an even digit. And I'm going to go up to my digit selection here and cross out all of the odds. Okay, so it can't be 1, 3, or 5. It's even. It must be 2 or 4. I'm a little tempted to test A and figure out what square is, but I also want a little variety of clues to help me eliminate possibilities for triangle and circle. So I believe I'm going to let's test the sum of the triangle and the square. So let's actually do criteria E. So let's test E out. Okay, so that is also incorrect. Notice in my proposal, my sum of the first and second digits, the triangle and square, is 4. The Turing machine said no, the sum cannot be less than 6, right? Because 4 is less than 6. So that means that the sum either has to be equal to 6 or greater than 6. So let me go ahead and do that. So that was for E. So I'm going to go here and say triangle plus square the sum needs to either be greater than 6 or equal to 6. Okay, so since it's not less than 6, it's got to be greater or equal to. Well, that said, can I eliminate any possibility? So again, I can't do anything to square, but what about triangle? Well, 1 plus 2 is 3, that's less than 6, and 1 plus 4 is less than 6. So I can actually eliminate 1 from triangle. But I can't eliminate any more because 2 plus, even though 2 plus 2 is 4, but 2 plus 4 is 6. So technically 2 is still a valid digit for triangle, since there is a possibility of it being either greater or equal to 6. And I think that's all I can eliminate. I can't eliminate anything for square. So yeah, because 2 plus 4 and 2 plus 5 meet these criteria. So yeah, I can't eliminate anything for square. Okay, so that was E. And so yeah, so let me then get something about the circle. And so let me test criteria D. So what does the Turing machine say about D? Okay, so D is correct. So again, I'm going to look at my proposal, and since D is comparing the middle and the last digit, so it is true that square is less than circle, since 1 is less than 4, and the Turing machine said that is correct. I know square is less than circle. So let me go ahead and do that. And that was for criteria D. So I'm going to go in my notes here and say square is less than, and it's circle. So square is less than circle. So are there any possibilities that I can eliminate? Well, I believe I can eliminate 1 for circle, since the smallest square is 2. That means I can eliminate 1 and also 2. I need circle to be greater than, so that means since the smallest possibility for square is 2, all my circles have to be bigger than 2. Okay, so I can't do anything else because again, I don't know anything about square, or I haven't eliminated anything for square. Okay, so that does it for our 3 Turing tests for our initial proposal. I now have to come up with something for the second round. Okay, so I haven't tested A, but that should be, a 50-50. So I don't quite know what that is, but the square can be either 2 or 4. I also have to test whether there's a 3. Notice that I still do have 2 possible 3s, so that is a worthy test. Again, a 50-50. Well, not 50-50, but yeah, there's 2 possible 3s. And then what else haven't I tested? And I haven't tested criteria F, whether they're all unique, is there a duplicate, or are they all the same? Well, let's see. For all the same, they would have to be all 4s. That may be a rare possibility, but still one nonetheless. There still are several pairs that could happen. So let me see. I'm not worried about A. That's a 50-50. Now, yeah, is there a 3? And F, is there a duplicate? So I'm thinking that even though we do know that square is less than circle, other than that, there's nothing else for us to eliminate circle values. So I'm wondering if somehow maybe circle could be the 3. Circle might be the 3. And so what would that mean for triangle and square? I definitely need to test either 6 or greater than 6. I do have possibilities 2 and 4 and 4 and 2. And that would eliminate this 3. And maybe then select that one. So let me do that. Let me test 2, 4, 3. So let me test 2, 4, 3. And yeah, let's try that out. Okay, so 2, 4, 3. All right, so first, I guess let me figure out whether triangle is 2 or 4. So that's an easy test. So A. So okay, so my proposal had square before, and it's telling me nope, it's not 4. So that means that I can eliminate 4 from here. So it must be 2. So in my notes section for A, I'm going to say that square is 2. Square is 2. Okay, so it's in fact, of course, since it's I chose 4, it's not greater than 4. It can't be equal to 3 because we said that it's not odd, and therefore it must be less than 3, and the only even digit less than 3 is 2. So that makes sense. Okay, let me test whether, actually before I test whether there's a 3, let me see what all 3 digits look like. So let me test criteria F. So let me check F. Okay, so we got a check mark, and that means that if I notice my proposal, they are all different. So that means that the Turing machine confirms that all 3 digits must be different. So that means there are no repetitions. So what we can say in our notes for F is that all 3 digits are unique. No duplicates and no triple numbers. So they're all different. So since we know that square is a 2, I can actually eliminate triangle being 2, right? There are no duplicates. So I can't have another 2. And that's the only one that I can eliminate. Yeah, so that means that, I have a combination of 3, 4, 5 for triangle, and again, some other combination of 3, 4, 5. So 2 of those numbers will be in my final code. So is there anything else I can test? So let's see. Actually, you know what? I can actually even eliminate 3 from a triangle, since I know square is 2. Well, 2 plus 3 is less than 6. So I can even eliminate the 3 for triangle. Now I can't eliminate 4 or 5 because that's 6 or 7. There's still that 3, that possible 3. So let's see. It may be a good idea to start listing some of these possibilities. And let me do it here in my C notes section. Okay, so I know for sure that the square is a 2. So that means I could have 4, 2, and then because I can't have any duplicates, it's either, circle is either 3 or 5. So 4, 2, I'll just put it as dash 3, 5. So 4, 2, 3, 5. Okay, and that would imply that the sum is 6, but easily I could also have 5, 2, which the sum would be greater than 6, and then the last digit is either 3 or 4. Is that right? 4, 2, no duplicates. 3, 5, can't repeat the 4. 5, 2, then 3, 4. So that is a sum that's equal to 6. That's a sum that's greater than 6. Both of these have a possibility of having a 3. So, yeah, it seems like I don't think I can eliminate testing E again and, C, in fact. Does it have a 3 or not? Does it have a 3 or not? Okay, yeah, I don't think I can deduce the final answer without doing some extra work. So, okay, so I'm just going to test C. So let's test C and see if there's a 3. Okay, so C. So C says no. So again, C, I do have a 3, and it's saying, in fact, I don't have well, it's incorrect to have a 3. Okay, so first of all, let me just say, because we have unique digits, obviously there can't be 2 3s or 3 3s, so those are impossible. But now this Turing test tells me that no, it is not correct to have a single 3. So in fact, there is no 3. Is that correct? It's telling me it's not correct that there's a 1 3. We've already stated that it can be 2 and 3 because of the uniqueness. So that means that there is no 3. Okay, so in my notes here, I'm going to say there is no 3. Okay, so let me eliminate the 3 from here. Okay, so that means that it can't be a 3, so it's either 4 2 5, no 3, or 5 2 4. Okay. So yeah, it's either a 4 or 5, so it's either sum is 6 and then a 5, or the sum is 7 and then a 4. Okay, so it's a 50-50. I'm going to try, let's just try 4 2 5. Anything else that I need to update in my notes? I don't believe so. I already said no 3, crossed them all out. And okay. Yeah, so the only thing to determine is whether the sum is greater than 6 or equal to 6. So let me try 4 2 5. 4 2 5 as my new proposal. Yep, I've done 3. Okay, 4 2 5. And again, I'm only going to test E, whether the sum is greater than 6 or equal to 6. So E. That is correct. The sum is 6. So that means it's not greater than 6. I can get rid of this or. Turing Machine confirms that the sum is 6. Yeah, since I chose 4 2, that's equal to 6. So the sum is 6. So that means it can't be 5 2 4. Okay, so again, our 3-digit code has to be, it's a unique code that meets all these criteria. So let's go back. Is square 2. We deduce that it's, we confirm that it is even and it's less than 3. So it must be a 2. Yeah, square is 2. Yeah, it's even and it's 2. We tested C and there should be no 3s. There are no 3s. Criteria D, compared square and circle. Is circle bigger than square? Yes. 5 is bigger than 2. Is the sum equal to 6? It is. 4 and 2. And are they all unique? Yes. Okay, so I feel confident that we have our code here, and that's 4 2 5. So let's go to the official Turing Machine test and confirm Well, let's go to our daily challenge. And this is today, May 6th, and that's the unique code for our Turing Machine Puzzle. Let's test the code, and again, that code was 425. So 425. Okay, verify. All right, congratulations, this is correct. But let's see if we beat the machine. So let's go back and see what did we test. So in our first proposal, we did BDE, 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 and I believe D was the only correct one. Yes. Then we did ACF, ACF in our second round, ACF, and that was correct. F was correct. And then finally we tested one more E, and it was correct. One more E for the third round, and it was correct. Let's see, how did we do? Okay, wow, we beat it by one question. We did it in 7 questions. The Turing Machine did it in 8 questions. So it was a grand success. Well, that does it for today. Thank you. Have a great one.